A penguin jumps from an iceberg into the water to catch its dinner. The penguin's height in feet f of x and the time after its dive in seconds x can be modeled by the function f of x equal to quantity x minus 4 squared minus 12. Part A is asking us what is the deepest depth that the penguin swims. In order to make sense of this problem, I'm going to make use of the concavity because the concavity determines if I have a maximum or a minimum. And here, the a value is going to be positive 1. If we have a positive value, then the parabola is going to be concave up. So we have a minimum. And this minimum is going to be representative of the deepest depth that the penguin swims. Furthermore, if we add an xy coordinate plane, the problem is telling us that the x-axis is represented by seconds. That means that the y-axis, or f of x, is going to represent the height. So then this value, h and k, h represents the seconds, so I'm going to put seconds, and k is going to represent the height. Now here, it's asking us the depth. So the depth, I'm going to associate it with the height. So we want the k value of the vertex. So to answer the first part, which is the question is asking you to find, I'm going to write the k value of the vertex. And the k value in R for our function, that's going to be negative 12. So our answer is going to be 12 feet. 12 feet below water. Or a depth of 12 feet. I should write here. Let me fix this. A depth of 12 feet. Part B is now asking what height does the penguin jump from. If we draw another quick sketch of the scenario, we can interpret this problem as the penguin jumping from this specific point here where the trajectory is crossing through the y-axis. So we can represent this scenario as the y-intercept. So here the question is asking us to find the y-intercept. And to find the y-intercept, we have to evaluate f of 0. So everywhere we see an x, we're going to replace it for a 0. So we get f of 0 equal to quantity 0 minus 4 squared minus 12. Now we have to evaluate this expression on the right, beginning with the parentheses. So 0 minus 4, that's negative 4. Quantity squared minus 12. Now we're going to evaluate the exponent. Negative 4 to the second power is negative 4 times negative 4, giving us a positive 16. And if we subtract 12, we're going to get 4. So the y-intercept is the coordinate 0, 4. But since we have an application, we got to interpret this answer. So we can say something along the lines that the penguin jumped from a height of 4 feet. Moving on to part C, now it's asking when does the penguin splash into the water? Again, drawing a quick sketch. Notice that the penguin is going to splash into the water at the first x-intercept. So we got to solve for the function. We got to let f of x equal to 0 and then solve for x. Now when we solve for x, we're going to get two solutions. So we have to get the smaller value, since the bigger value is going to represent when the penguin exits the water. So let's go ahead and do this. So setting f of x equal to 0, we have the equation 0 equal to x minus 4 squared minus 12. To solve this equation, I'm first going to get rid of the constant. So to get rid of negative 12, I'm going to add 12 on both sides. And on the left hand side, 0 plus 12, we get 12. On the right hand side, the 12's cancel out, leaving us with quantity x minus 4 squared. Now to get rid of the second power, I'm going to square root both sides. On the left hand side, I get the square root of 12, which I'm going to have to approximate using my calculator. I get an approximation of about 3.5. And on the right hand side, the square and the square root are going to cancel out, leaving me with x minus 4. And also on the left hand side, we actually have a plus or minus. Now to isolate x, we have to add 4 on both sides. And on the right hand side, I get x by itself, so x is isolated. So x is approximately equal to 4 plus 3.5, or 4 minus 3.5. And again, we want to get the smaller value. That's going to be this one on the right. So let's go ahead and solve for this. So 4 minus 3.5, that's going to be 0.5. So x is approximately 0.5, and that would be our solution here. So the question is asking us to find the x-intercept, the first one. I'm just going to write x-intercept here. And then the answer is going to be the penguin splashes into the water at 0.5 seconds. Finally, to address part D, at what time does the penguin reach a depth of 8 feet below water? Now here, notice that a depth of 8 feet, we're going to represent this with a negative 8. So we got to let the function equal negative 8, and then we have to solve for the time x. So here, the question is asking us to find, or it's asking us to solve for x when f of x is equal to negative 8. So here we have the equation negative 8 because we're replacing f of x for this. And that's going to equal x minus 4 squared minus 12. So now solving for x will give us the time when the penguin reaches this depth of 8 feet. So let's begin by isolating, or actually we should begin by removing the constant here. So we gotta add 12 to both sides. On the left hand side, negative 8 plus 12, we're gonna get positive 4. On the right hand side, we're just left with x minus 4 squared since the 12s are gonna cancel out. And now to undo the square here, we're going to square root of both sides. On the left hand side, the square root of 4 is going to be plus or minus 2. On the right hand side, square and square root cancel out, leaving us with x minus 4. Finally, to isolate x, we're going to add 4 to both sides of the equation. And then that's going to leave us with the two solutions here, 4 plus 2 and 4 minus 2. Let's go ahead and solve for both of these. So we're going to get x equal to 4 plus 2 is 6. And then 4 minus 2, that's going to be 2. So here are the solutions. Hence, the penguin will reach a depth of 8 feet at 2 seconds and again at 6 seconds. The first time it reaches 8 feet, that's when it splashes inside of the water. And then it's going to reach 8 feet again once it begins to exit the water. And there you go.